Look at how fast the skaters are. They're really like flying on the ice.
Applying aerospace knowledge and technologies to ice and snow sports is actually quite reasonable. They share many similar scenarios, such as selection of trajectories or how wind drag affects movements and speed.
When the athletes are skating, oftentimes the process resembles the flight of a plane. That's why we describe it vividly as flying on ice.
Professor Ke Peng was a great hand to winter sports when he was first invited to coach China's Winter Olympic teams 4 years ago. Back then, he was only an associate professor in the School of Transportation Science and Engineering of Beihang University. Now, he has earned the title of Ice and Snow Scientist in China because of his contribution to winter sports.
You have to slow down when making turn, otherwise you'll be thrown out. If you don't slow down, you have to take a wide turn, then the route will be longer. The trajectory we optimized using mathematical methods is similar to the actual one taken by top skaters.
Speed skating is an ice sport that plays on sharp edges, cutting across ice. Professor Ke's team similarly applied cutting-edge technologies to push athletes' performances as well as the quality of their equipment to their extreme levels.
After further exploration, we envisioned using the technology of aerospace boosters. We designed this small device with 2 ice blades installed at the bottom to simulate ice skates used by our athletes. 2 electric-driven fan propellers are installed on top, one for accelerating and one for decelerating.
Will you show it to us?
Sure, let's check it out together. This device simulates the weight and speed of athletes and then tests the friction coefficient between actual blades and the ice surface. The friction is relative to specific conditions of the blades as well as the ice surface. Therefore, we can test different blades to see which has smaller friction coefficient and better performance on the same ice surface.
Design for this light strip is also sparked by plane landing practices. The colorful cursors can move with a predetermined speed along which the athletes can follow for speed practices.
The landing trajectory of an aircraft is actually optimized. In the aviation sector, we calculate optimal glide paths from an economic and fuel-saving perspective. The strategy is similar for ice skating. Given the limitation of an athlete's capabilities and stamina, we optimize the best strategy for matched speeds.
Now, Professor Ke's team is exploring more application scenarios of their innovation in sports. For example, adjusting the light strips underwater for swimmers to recognize and improve their speeds. Who knows, maybe your next pair of ice skates will have blades empowered by aerospace technology.